All right, guys, here's a little bit of homework help on this day 3, the converse of the Pythagorean theorem. You have those first 6 problems you have to do, and again, just a hint, I'm not going to do them all or anything, but just a reminder, when you go through these, make sure that you are labeling, okay, this is my biggest side of the 3 sides, so that's my C, and the other ones are A and B. Then same thing here, this one is C for this particular set, and this one is C for this set. And again, when you plug them in, let's say, okay, then I label this one A and this one B, so when I start putting them in with the formula, here's what your work will look like. 4.5 squared plus 4 squared equals 7 squared. And you got to square each of the numbers and add them together. I think this one ends up being, something like 20.25 plus 16 equals 49. Again, question mark. I'm trying to figure out if this works. And then when I add those together, add these two. Again, you can double check the numbers, but I think I'm getting 36.25, and that's less than 49. So again, the A and the B, this side had the A and the B, right? We squared those, we add them together. That side is less than C, so that biggest side is longer than it should be for right triangle. So that makes the obtuse case, just as a reminder. So 3 should be obtuse, just as a hint on one of them. All right, then the parts of the assignment that people probably need a little more help on is these last 2 word problems. Again, I'm not going to do them, but let me give you a little bit of hint and insight on each one of them. This number 10 starts off that Frank Road and James Road make a perpendicular intersection. We know what perpendicular means, right? Upside down T, that means they make a right angle. So you can imagine that, okay, here, that's a terrible line, you guys. I'll try to do better here on this one, but straight down, straight across, let's say that's a right angle right there, okay? They make a perpendicular intersection. There's my 2 roads. So they make a perpendicular intersection, and the state wants to build a new road, okay? And the new road will intersect, kind of road over here, but intersect 3 miles north of that intersection. So 3 miles north of the intersection on Frank Road. So this one is Frank Road, and this right here, this distance is 3 miles. Okay, and then 4 miles west of the intersection. So 4 miles west over here on James Road. So this is 4 miles. And they're saying that they want to make a new road that connects those two. Oh, okay. I'm going to leave it to my picture there to help you. That may could help you figure out what you're trying to do, because you're trying to figure out how long that new road is going to be. And then also, something else that asks on Schoology, it says a new road would cost $10 per foot to pave. Realize that the units, this kind of goes back to 7th grade stuff and stuff you've done in the past, but this is in terms of miles. So you're going to have to figure out how many feet that is. And there is a conversion from miles to feet. You can look that up on the internet. I bet you'll be able to find that if you type it in too, or maybe some of you know it. You have to use that to help you figure out how much is it going to cost for the new road. Okay. Then going down to that other one, number 11. So the mobile phone company is anchoring wires to the top of their 1,200-foot high communication tower. So just in general, they have towers here somewhere, okay, and these are 1,200 feet high, 1,200 feet, okay. The cable they use to support these, wires used to support these towers, okay, what they do is they take a wire then and they tether it to the ground like this. And then, what do you know, you're going to have to figure out how far it is from the base of that. So again, you'll be making some type of right triangle shape here. But something that's important is you got to figure out how long this cable is that they're going to use to tether it to the top of the 1,200-foot tall pole. Well, here's my hint to you. They say that the support wire, comes in rolls that is 3,900 feet long. But they're not going to use that here for that whole support cable. They got to cut it down because it'd be too long. The cable they get, that 3,900-foot roll, can only be cut twice. I think it says here somewhere, right? It can only be cut twice to ensure its strength. So think about it. They're going to roll out this big wire. They're going to uncoil it, okay, all the way from end to end. And this whole thing is 3,900 feet, okay? But then they're going to cut it twice. And so that'll give them more wire to work with. And if they cut it twice, they're going to cut it so they get 3 equal pieces, right? So you're going to cut it maybe like, let's say, here and here. And they're going to take one of these sections right here, let's say this middle one, and that's what they're going to use to tether it up here. So you have to kind of think about how long that's going to be. I bet you have ways that you could figure that out, but that's what you have to consider. It will not be the 3,900 feet there. It'll be once they've cut this into 3 equal sections. Take one of those sections, and that's what's going to go here. Okay? Use that to help you. If you still need more help, again, let me know. Email me or Zoom me.